Welcome! Today I'm going to show you the strategy design pattern in the context of JavaScript. The strategy design pattern is used to execute variations of algorithms which can be used to achieve similar results. In this case, I'll show you an example with sorting algorithms. We can use multiple sorting algorithms for different reasons, and we need a single API to execute them all. Let's jump into the code and we'll see how it works. Okay, let's begin. I want to show you the design pattern in both JavaScript and TypeScript because in TypeScript we can do more. We can implement interfaces, for example. This is why I have prepared two empty JS and TS files. We'll test everything in Node.js basically. But that's not important. The environment, whether it's browser, Node, Babel, transpilation, doesn't matter. The design pattern is something more general. So we want to implement a strategy pattern in this case for two sorting strategies, MergeSort and QuickSort. These are just examples. You would probably use it for something more specific to your business use case. There are many business related tasks that have slightly different algorithms that achieve similar things. And you can group these algorithms by type with the strategy pattern. Sorting is just one example. I can use that as general and most people will understand kind of what the idea is this way. So to do that, I'll call my main class sorter, and it will have a constructor which will accept a strategy. And this strategy will set as this strategy. And this class will be able to set that strategy additionally with a method in order to be able to change it after we initialize the object. And then finally, this class will only sort. So we have a sort function. This function will usually accept an array and do some functions, but here we don't need that. We don't need the sorting implementation specifically. We care about the design pattern, so I'll just console walk. And in this case I won't console walk because this is the sorter, the strategy pattern base container, which will just execute this strategy sort. And if we have an array here, we can pass it over to that object. In this case, I won't have any data. And let's just do a check. If this strategy is not available, we'll just return no for safety. Now, the strategies in JavaScript are just going to be objects. Let's say we have a MergeSort strategy. All it needs to have is a sort function that will console walk MergeSort. This is how we're going to differentiate that from QuickSort, which is going to be another object and a strategy. Okay. So I have MergeSort and QuickSort. Now, how do we use that? We create a new sorter, which is using the strategy pattern, and we can pass an arbitrary strategy. In this case, I'll pass MergeSort in it, and then I'll execute sort once. Then I'll change the strategy with the set strategy to QuickSort, and then I'll execute another sort. Now, if we test that, we should be getting the following result. We have to run, and we initialize the sorter with the MergeSort strategy. So this first sort should run this algorithm. MergeSort should be output to the console. Then we change the strategy to QuickSort and we execute sort again on the base sorter API. So in that case, we should get QuickSort. And if I execute my script now with Node, I have a syntax error right here, just a quick typo. And if I execute again, we get exactly what was expected. MergeSort and then QuickSort. Let me clear the console. Now in TypeScript, we can do more. I'll copy this JavaScript code and paste it in my TypeScript file. So first of all, we can have an interface here for strategy. I'll call it sorting strategy, and that interface will be what strategy needs to have, and that's a sort function. This is the required basics for the sorting strategy. And now in the constructor, we pass a sorting strategy. Of course, this strategy needs to be defined. And here we can set types. Now, that is all good. Duplicate identifier sorter. Where do we have a sorter? We'll see that. So MergeSort will now be a sorting strategy, of course, and QuickSort as well. Let me check. There seems to be some IntelliSense error right here, which I'm getting, which is not real. And it was coming from the index JavaScript file. So because I had my TypeScript and JavaScript file in the same directory, this code was presuming that they were in the same scope and there would be conflicts. But that was not true. So I set these as sorting strategies now, so we know what kind of interface we're using. And this is a big advantage to TypeScript. If you want to really implement design patterns and real structure and architecture, I would advise you to use TypeScript instead of plain vanilla JavaScript. And now we can use the same API basically. New sorter, MergeSort, QuickSort, but we have more safety here. We are typing real objects which have an interface and we know what to implement and we'll catch errors in case we haven't implemented completely the strategy early during TypeScript compilation time. Let's run that with TS node, TypeScript node, just to validate it works, and it works exactly the same way. And this is how you can use the strategy pattern to use multiple families of algorithms with the same API. In this case, the adapter we use, the actual API client that the clients are using, the class that holds the API is sorter. And the strategies are different implementations of the algorithms we can set for that actual API to use. This way we can create a new sorter, execute sorts whenever we want, then change the strategy, execute other sorts. We can use a different strategy for each time we want to sort an actual thing. We can first set the sort we want and then execute the algorithm. This is very powerful, extremely useful. It's used throughout code bases all over. You should know it. It's a very basic and essential design pattern in software design. With this, I'll wrap today's video. If you enjoy the content, don't forget to subscribe to get notified when I release another video. Take care.